All right, this is the chapter 2, or algebra 2, chapter 4 review, part 2. The first part is we want to draw a polynomial with left behavior. So on the left-hand side of the graph, it's going to be approaching negative infinity. So on the left-hand side, I know it has to be going down. So I started by just drawing that down. That'd be my first step. And then it tells us we have zeros at -1, -2, and a double zero at 3. And that double tells me that it's just going to hit the graph and bounce off, and 1 at 5. So I just started by drawing, going through those, and when I got to 3, I knew it was just going to bounce back and then go through. On number 2, I wanted to graph that. So I've got a double zero at 3 and 1 at -3. It is a cubic function because I have 2 x's here and 1 here. So it's an odd degree with a positive leading coefficient. So it's going to be down, up. And I wanted to get a little bit more accurate, so I wanted to know what my y-intercept was. So I put 0 in. And if I put 0 in, I got 27. Well, I didn't want to do 27 hash marks, so I said I'm just going to count by 9, 9, 18, 27. So my y-intercept is 0, 27. All right, on number 3, we want to find the zeros and graph the function. I didn't graph it. I'll let you do that. Show your factoring for full credit. I thought that was the more important part right there. So if I were going to be doing this, the first thing I noticed was I have a GCF of negative 6x squared. And I pulled that out and I was left with x squared plus x minus 8. Well, that part doesn't factor. I know I have a double root at 0, so if I wanted to, I could put that double root in right there. And then for the x squared plus x minus 8, I'm going to need to use the quadratic formula. So on that one, just figure out what your a, b, and c are, and you're going to want to go with that. And plug it in, and underneath the radical, you're going to get 0, 0, and you can plug that in and kind of figure out what that is approximately. I guess if I had the calculator right now, I could do that. -1 minus the square root of 33, and then divide that by 2, and I got negative 3.37, and then -1 plus the square root of 33, divide that by 2, and I got 2.37. So you would have something, whoops, I'm going the wrong direction because that's a negative leading coefficient. You're going to get an M-shaped on that one. So did I get all of those? Yep, next page. On the given set of axes, sketch an even degree function with a positive leading coefficient. Well, if it is even and positive, the left-hand side goes up, the right-hand side goes up. And the function should have 3 zeros, 2 local maxima, there are my maximums, and 3 minimums. My minimums are the low points. Let's make the minimums in blue, and my maximums in green. All right, number 5, sketch an odd degree with a positive leading coefficient. Well, that means the left-hand side is down, the right-hand side is up. The function should have 4 zeros. 1, 2, 3, 4. 2 local minima, right there, and right there, and 2 maximums. So I had to make that one of them a double root, so that the directions were going the right way. So on number 6, the function below is degree 4. How many imaginary roots does it have? Well, if it's a 4th degree, you've got 4 zeros, and 2 of them are right there, so 4 minus 2 is 2 imaginary. All right, state where the intervals of the polynomial is increasing and decreasing. Well, it is increasing from negative 1.25 to 0, and from 1.25 to infinity. Again, you're looking at the x values. It's decreasing from negative infinity to negative 1.225, and from 0 to 1.225. And the minimums and maximums, I gave those as the ordered pairs. All right, we want to find our zeros of each function. You must show work to get an answer. So first thing I do is I look at my graph. And hey, looks like I've got one at 1 and at negative 1. So I'm going to start those off with my synthetic division. And I need to put in a couple placeholders because I don't have an x cubed or an x. So you're going to have 2 placeholders. I bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and my remainder is 0. So since my remainder is 0, I know that x equals 1 is negative 1 is a root. Now I'm going to do 1. I bring down the 1. 1 times 1 is 1. Add. 1 times 0 is 0. Add. 1 times 8, 8. Add. And I'm going to be left with a quadratic. X squared plus 8 equals 0. I solve for x, subtract it over to the other side, and I just noticed a small little mistake, so I'm going to fix that right now. That should have been a negative 8, which means that I should have an I right there. So I need to put an I right there and right there. Whenever you've got a negative underneath the radical, you're going to have an I. So let's probably write that a little bit nicer. Plus or minus 2I radical 2. All right, on this one I want to find all my zeros. So first thing I look at my graph. Now that's not an integer. That doesn't look like it's an integer. That one looked like 1. That would fit into the rational root theorem. I'm going to put 1 in my box. I do need to put a placeholder. So I bring down the 1. 1 times 1. Add. Multiply. Add. 1 times 8. Multiply. Add. My remainder is 0. So I know x equals 1 is one of my solutions. And I'm left with x squared plus 8x plus 8. I need to use the quadratic formula on that one. And 8 squared minus 4ac, I'm going to be left with 64 minus 32. So that's where that 32 underneath the radical comes from. 32 can be simplified down because that could be 16 times 2. 16 is a perfect square. So I can pull a 4 out, and the 2 stays underneath the radical. All my terms here are divisible by 2. So I'm going to be left with negative 4 plus or minus 2 radical 2. On 11, I wanted to do that one with grouping. So I grouped the first two together, grouped the second two together, and I pulled out an x squared out of the first group and was left with x minus 4. Pulled a negative 10 out of my second group and left with x minus 4. I've got the same thing in my parentheses. So I'm going to have x minus 4 times x squared minus 10. I can set each of those equal to 0 and solve. And it doesn't turn out nice and neat. I get the square root of 10 plus or minus. And I used my calculator to figure out that was approximately 3.16. So I just kind of estimated that on the graph, and x equals 4. And my end behavior, because it's odd degree and positive leading coefficient, is going to be down, up. All right. Number 12. Determine the cubic function that is obtained by the parent function. So my parent function is x to the 5th. So on this one, I'm going to be going, oops, wrote x squared. I'm going to be going 5 units up. And then I'm going to be going 5 units to the right. That needs to be paired with the x. And with the right, it's going to be a minus. So that is going to be my new function right there. 5 units right, 2 up. This one, a reflection in the x-axis, followed by a vertical translation 3 units down. And there we go. Write a polynomial with a coefficient of 1 that has roots of 5, negative 5, and 2i. Well, imaginary never travel by themselves. I always have to have a partner. So I'm going to have x plus 2i, x minus 2i, and x plus 5. Always FOIL your conjugates first. Your middle terms should cancel out. And remember, I squared is the same as negative 1. So negative 4 times negative 1, that's why that's a positive 4. And then you're going to have to FOIL again. Graph, well, I've got x equals 3, and that's a double root, so it just bounces, and negative 4. So there's my 3 with a bounce, negative 4. My end behavior is down, up, because it's an odd degree with a positive leading coefficient. All right, on 16 through 20, we just needed to correct them. A polynomial function has roots of 3 and 2i. The degree will be 3, because you have to have a second one for that. Imaginary. A polynomial function with an odd degree has at least one real root, because it has to cross the x-axis. The possible rational roots for this function are listed right here. If it's got a root of 2 minus 4i, you only change the sign that's in between, so that would be 2 plus 4i. If a polynomial has an even degree, it is possible to have only real solutions. Yeah, that's true, but I added on, or only imaginary solutions or a combination. So that was kind of a trick question. All right, hope you enjoy.